Hello, my name is Graham Bell. I'm a co-founder and managing director of NextAero. We have been developing a type of high-performance rocket engine called the Aerospike, and our proof of concept tests have gained the interest of some industry partners because there is the potential to reduce launch costs by around 25%. The main performance benefits of the Aerospike are that it produces more thrust at a lower altitude, and that's when the rockets are typically heavier, more with fuel, so you're basically getting more power at sort of a harder design condition. Because there's so much complicated internal geometry, it's very difficult to manufacture that. With 3D printing, essentially we can define the geometries that we want and print them. This is an Aerospike style engine. The Aerospike is just this section at the front. The main differences between an Aerospike and a nozzle you've perhaps seen on a Falcon 9 rocket is that the nozzle section would otherwise be out here. With an Aerospike, you essentially flip that profile and you're actually able to push it back inside the engine. So it makes a smaller, more compact engine. So this engine produces around 400 kilograms of thrust. A typical engine that you would find on an actual launch vehicle in this size would produce about 1 ton of thrust, and you'd use perhaps 7 engines. To overcome some of the challenges with cooling the engine, we've used a combination of fluid mechanics knowledge and modelling inside the engine, as well as 3D printing. So working with customers to try and understand their problems and potential problems that they haven't identified even is quite challenging. Coming from a technical background, it's not an innate skill. It's something we've certainly had to develop more through an entrepreneurial process. I think that you have to be quite patient, quite curious, and certainly I guess very knowledgeable about the technical aspects to identify the problems. Within the university space as well, we're very fortunate to have access to basically more resources from different entities like Monash University, Aero Engineering, Woodside Energy as well. So 3D printing in metals is particularly challenging. There are a lot of thermal concerns and structural concerns that you need to take into account. The engine is made from an alloy called Hastelloy X, which is a pretty common aerospace 3D printing material for making very high temperature parts. So we've been working within the startup quite diligently on identifying the customers. For us in Australia, we partner quite well with Europe and Asia. So we've been looking at a couple of companies there like Orbex, Sky Aurora, PLD Space, for example. So the market is in quite an interesting spot at the moment. There have been some players around for around 5 years developing vehicles and engines, so that's essentially Gen 1. Right now we're sort of seeing the next stage come along, so we're seeing some emerging players who need a point of difference, an improvement in performance to justify that commercial case, and also we've got the existing players essentially trying to improve performance. So NextAero essentially slots in as an upgrade for existing vehicles and an off-the-shelf option for new vehicles. The existing rocket motor manufacturers, they are mostly United States based. They have very large contracts and established contracts with very established companies, particularly defence primes in particular. So what we're focusing on is certainly more in the private small scale, small enterprise market.